One way to reduce cloud costs when building machine learning models with SageMaker is by utilizing your local environment for development, instead of relying on SageMaker notebooks or SageMaker Studio. This approach is especially helpful for those learning the service and want to keep expenses low. So, in this video, I will show you how to set up your local environment to develop SageMaker models right from your own machine. If that sounds like something you are interested in, then let's get started. The first step in setting up a local development environment for AWS SageMaker is to download and install Anaconda. To this end, navigate to this website and download the Anaconda distribution for your system's operating system. Mine is Windows and I've already downloaded it. After downloading it, click on it to start the installation wizard. So I have mine here, so I'll click next. I agree. Choose just me. Then choose your destination folder. I'll leave the default showing here. And please uncheck this and just leave everything as it is right here. Then you install. It takes a while, so we'll just wait for it to complete the installation and we'll continue. Installation is complete, so we click next and next, and you just uncheck this. We would like to have the Anaconda Navigator launched once we finish, so we click finish. When the Anaconda Navigator interface launches, we will move to step 2, setting up our virtual environment. With the Anaconda Navigator interface open, we are currently in the base environment. So next, we click on the PowerShell prompt to enter the command line environment where we'll set up our own environment. We are now in the Windows PowerShell environment, so we will activate a new environment called SageMaker Dev using this command. Here, as mentioned earlier, SageMaker Dev is the name of the environment, and Python is set to version 3.10 because at this time the SageMaker API requires Python 3.10 or below. I encountered issues when using a higher Python version. So we will create this environment. Yes. It takes a while, so we'll just wait for it to complete. It's done creating, so we will activate this environment using this command, conda activate SageMaker Dev. So we are now in this new development environment. Now that our new environment is created, let's move on to step 3, where we install the required packages. In this demo, we will need 5 packages, Boto3, AWS Command Line, SageMaker, Scikit-learn, and Jupyter Lab. I will install them one by one, but you can also install them all at once if you prefer. First, I will install Boto3, which interacts with AWS programmatically. Next, I will install AWS Command Line to interact with AWS services directly from the terminal. Takes a while, so we just wait. Next, we install SageMaker, which is an SDK for interacting specifically with AWS SageMaker. Next, we install Scikit-learn, which is what we are going to use to build our machine learning model. Finally, we'll use conda to install Jupyter Lab, which we'll use to create and manage our Jupyter notebook. Yes. Jupyter Lab is now installed, so finally we create a Jupyter kernel called SageMaker Dev. Next, configure your environment with AWS credentials so that you can successfully communicate with AWS resources. You do that using AWS configure, and I will just go ahead and enter. Now that we've installed all the required packages, let's move on to step 4, launching the Jupyter Lab environment we just set up, and do a quick SageMaker model development. I have navigated to my VS Code where I have my development scripts, and within the terminal I will start the Jupyter Lab. Now our Jupyter Lab is up and running, as you can see. we have this local training notebook, which is what we are going to use for the training. So first, make sure that you're in the right kernel. Remember when we created this kernel, so that's what we're going to be using. Okay, so now we'll move on to running the code. We import the necessary libraries, and we have our SageMaker session and role. Hopefully you know what that means. And next we go into the training proper. The training input part, which is this, is the link to where my training data is stored in my S3 bucket. And this output part here is where I want to store the model that we will build shortly. This indicates we're using sklearn framework to train this model, and for the entry point we are referencing the train.py file, which is this file contains our training code, and we have our role, the instance count, the instance type, our framework version, and number of estimators. I will change it to 4 so it trains even faster. So we're going to go ahead to run this code and train our model. So the training has commenced, and it takes quite some time, so we just wait and come back when the training is complete. So our training is now complete, as you can see, and this model has also been uploaded to the output path we specified. And to confirm that, we navigate to my S3 bucket under model artifacts like we have. You see the model that just got uploaded, and you click on the output, you see the model that we just trained here. So we are going to copy this S3 URI because we are going to use it. So now let's quickly deploy the model. We are going to paste that model URI we just copied here. And of course the role is the same. We are specifying the same framework version like we used during the training, and we also referencing our train.py file because it also has the function that will be utilized for the inference, which is this model func. So and we are going to use this object here created by the sklearn model to deploy this model. So we're going to go ahead and run this code. So the deployment is just starting and it's trying to create the endpoint. So our deployment is complete by the indication of this exclamation mark here. So if I check now on my SageMaker inference under endpoint, I hope to see one endpoint that is running, and this is what we just deployed, this endpoint. Finally, we are going to test this endpoint. This I'm just reading in my test data set, which is what I have in here. So I just go ahead and run this. Finally, here we are passing our test data, which is testdf, to this predictor.predict method. Remember, this predictor is what is the object we created when we made the deployment. So we're just passing the test data and we are comparing it with the real actual label. So let's go ahead and run this code. As you can see, here are the predicted values. So that means the test data was able to interact with our deployed endpoint, which is indicated by this predictor, and you can see the classified output almost identical with the actual values. And with this, we come to the end of this demo. I hope you found this tutorial helpful. Thank you for watching, and I look forward to seeing you in the next one. Don't forget to like and subscribe to this channel for more insightful tutorials.